Alright, here's the homework help video for the day 3 worksheet that I assigned from Friday. The ideas here were either to look for a greatest common factor or to try factoring something. So I think the tricky part with this one is realizing what to do. I think maybe or hopefully you're thinking about factoring that top, but how to factor the top. So that's really like having u squared minus another letter v squared, where u is taking the place of sine x, but v is taking, and v is taking the place of cosine x. So in order to factor that, you're going to have to use the perfect square method. We can break this down into u minus v and u plus v. So literally that whole top is going to turn into sine x minus cosine x times sine x plus cosine x. That's all over sine x minus cosine x. And it's supposed to equal sine x plus cosine x at the end. So then from there, you can cross these out, and they cancel, and we get sine x plus cosine x equal to sine x plus cosine x. You'll run into a problem in this one if you try and take, I can see kind of what direction some of you may have tried to go. Like you can take sine x and you can figure out what that is and you can replace it. You'll run into a problem there that you won't be able to solve that if you try and do it that way. So try and factor. If we have a fraction and the bottom's just magically disappearing, there's probably some factoring that's going on and how you're getting the bottom to disappear. Alright, let's look at the next one. Alright, this is number 4. This one I would definitely recommend. We can factor out the top here. We're going to use the u method to factor out the top. So it's going to be u is equal to, that's going to be the middle term, secant x. So it's going to be u squared. I see what's wrong here. There's a typo. There's supposed to be a squared in there. So secant is actually, the u is supposed to be secant squared x. So that's probably what was throwing some of you off. There's a typo there. With the squared in, we can do u is actually equal to secant squared x then. And it'd be u squared minus 2u plus 1. U minus 1 times u minus 1 is what it factors to. I apologize for that typo. So it's going to be secant squared x minus 1 because we called u secant squared. And then times secant squared x minus 1 over secant squared x minus 1 equals tangent squared x. One of these cancels with one of those. We still have one left. So secant squared x minus 1 is equal to tangent squared x. And what I would do here is look at what we know. Secant squared x equals, right over here, I know I can take that secant squared x and I can plug in tangent squared x plus 1 minus 1 equals tangent squared x. And those 1's cancel out, so we get tangent squared x is equal to tangent squared x. Check. So if you fix my typo there, then it should work out quite nicely. Alright, number 6. And again, the two ideas we were talking about is either factoring or taking out a greatest common factor. So when you look at this one, they both have a sine x. That's where I'm going to start, is I can take the sine x out. I'm left with 1 plus cotangent x. Cotangent squared x equal to cosecant x. And then I can look for a replacement for that 1 plus cotangent squared x. That is actually equal to, if we look at over here, I can replace that whole thing with cosecant x. So it's going to be sine x times cosecant squared x has to equal cosecant x. And then you can go one of two directions. You could change this right side here. You could change the sines and cosines, which is probably what I would do. So I'm going to walk through that. You could also just take sine x and change it to cosecant x, which would be a little bit shorter. But I kind of default to the list of things I gave you guys, so I'm going to follow the rules there. So that's cosecant x is really 1 over sine squared x equal to cosecant x. This one then cancels with one of those. So we have 1 over sine x left equals cosecant x. And then if I try to rewrite that, it does flip over and become cosecant x. Cosecant x is equal to cosecant x. So if you look on your plate, you do know that 1 over sine x does turn into cosecant x. So I hope that helped. That's not the only way, like I said. You could have, from this step here, instead of changing the cosecant squared x, you could actually change the sine squared x. It's a faster problem that way. Or just the sine x. Is I know that sine x is 1 over cosecant x times cosecant squared x equal to cosecant x. If I put this over 1, one of those cancels, so we just have the 1 left. Cosecant x equals cosecant x. So you could do it either way. Whichever one makes more sense to you, whichever one pops in your head first. Alright, the last one is number 9. This one is a factoring one right off the bat. I can tell this top, I can kind of factor that down. So I'm going to make u equal to tangent squared x. So that's going to be u squared plus 5u plus 4. Factors of 4 that add to 5 are 4 and 1. So that's u plus 4 times u plus 1, and then we can work that into our problem over here. So instead of u, we're going to plug in the tangent squared. So it's tangent squared x plus 4 times tangent squared x plus 1 over tangent squared x plus 4 equals secant squared x. And then these cancel out. Left with tangent squared x plus 1 equals secant squared x. And I'm sensing, since this is a trig squared and a 1, I'm sensing there's something I can do over here. So if I look here, tangent squared x plus 1 is equal to secant squared x. So we can just plug that in. Secant squared x is equal to secant squared x. Done. Alright, I hope that helps. Good luck on the recap today. Again, I'd like you to turn it in, whatever you have done, by the end of class. But if you have questions, come and see me after school. If you have questions, I'd like to work through it with you. I'll give you more time to work on it after school. But it needs to be turned in before you leave. Alright, and then you have no other homework. So have a good rest of your day, and I will see you guys on Tuesday.